Hello everyone, myself Deepika Sharma, and today in this video we are going to see the demonstration of the project which I have implemented. The project is called end-to-end DevSecOps CI CD pipeline, and this is done using the GitHub Actions. So as we know, there are multiple tools for CI CD. The famous one is Jenkins, but this time we have used the GitHub Actions for our CI CD flow. So let me brief about this. First, we will just see the brief about the project, what we are going to do and what kind of setup we need, and then I will do the hands-on, and then we can move ahead to see the real deployments from source code to the EKS cluster. So let's begin. First, as we talked about, it is about the CI/CD pipeline. So as we see, this is CI/CD with GitOps. So here, what is the main concept we are dealing with? CI/CD, as we know, it's a continuous integration and continuous deployment. So for the CI part, we have used the GitHub Actions, and in GitHub Actions we have written the GitHub workflows. We will see in the future, and then we have some security scans which will scan our source code and our manifest as well for the security purpose, and it will make sure like nothing serious or severity issues are there in the code. Also, we will be using Docker for the containerization of the image, and then for the CD part we have integrated Argo CD, which will make sure like whatever we are pushing the latest image, it will getting deployed in our Kubernetes cluster, which we will host in the AWS console. So yes, if we move ahead, we can see like what are the prerequisites I have implemented. So we should have VS Code for obviously writing codes, AWS console admin, then GitHub for source code management, and we should have one CLI from where we can connect our Terraform, our AWS console and all these things. So I am using Git Bash, then Terraform for infrastructure provisioning. In this project, what I have done is from starting end to end, like infra also I have created using Terraform. So it is a combination of multiple projects which will demonstrate like Terraform to the EKS cluster, CI/CD, and also the deployment. We do also need the sonarqube setup, Snyk dashboard, and then JFrog, Docker Hub, and we also need one runner. Okay, so we will check like what is it in the coming video. Then if we see about our CI/CD pipeline, so this is how my CI/CD pipeline looks like. So we can see like here is the developer, and before this there are few steps which is like we can just discuss it in a minute. Like definitely there is one delivery team or the delivery team which gets the requirements from the client, and as per the client requirement there is scrum calls and everything. It is decided how we are going to proceed, and then they'll create the stories task in the Jira or any tool. Then the Jira will be assigned in the developer team. So once the developer team will work on the task, whether it is a changes or any updations or any any feature updates, new feature integration, anything. So basically they are making changes in their source code. So from here to here it is a developer task. So what they are doing is they are making changes in their source code and they are committing in our source code management. So here I am using the GitHub for that. So from here our DevOps task started. Once the source code is committed in the GitHub, then what will happen is it will first initialize unit test, like okay, everything is working fine, nothing is breaking if after making changes. Then it will scan using the sonarqube. It is a scanner, so it will scan using the sonarqube, and then also it will scan using Snyk. It is for checking the vulnerabilities in any code, like if we mention the dependency in the pom.xml, so yes, it will check that everything. Once it is passed, then we will move ahead and build our artifact. Once that artifact is built. In our case, it is a Spring Boot Java based application. So definitely for building we will be needing Gradle or Maven. So I have used Maven. With the help of Maven, our application will be built, and then with the help of that, it is called the artifact. That artifact can be stored either on the GitHub itself or on the JFrog artifactory. So once that artifactory is ready, then we can push it to any remote repository. In that case, we can use JFrog artifactory as well, or in the GitHub itself we can store that. That build, what that jar is ready, then what it will do is, with the help of Docker file, it will create the Docker image. With that artifact we will create the Docker image, and that Docker image will be tagged. Maybe we can tag it latest, or we can tag based on our git commits, SHA, or there are multiple methods. So with that we will tag it, like we will give some unique specification ID, with the help of which we can version it and check like which is the latest one, and that image will be pushed in our Docker hub. So from there what it will do is, once this Docker image is pushed, our CI part is completed. Now for the deployment, we have integrated the Argo CD in our EKS cluster, where it will check like what is the current working image version and what is pushed in the GitHub, and it will make sure like whatever the latest image is pushed, it is getting deployed successfully, and the application is available with the latest code changes. So yeah, this is our end-to-end CI CD pipeline, and we will discuss it hand-to-hand, hands-on in a coming video. So now I'm just showing you the basic home page of our Spring Boot application. I know like it is not very dynamic and very attractive website, but for now this is not about the development, but it is about the deployment. So we will just focus like our application should be up and running, and here we can see it is a Kubernetes cluster load balancer URL where my application is up and running. So yeah, this should be up and running once we do the hands-on. Coming to the implementation part, we have few steps. So first of all, we should be creating our infrastructure where we will building the CI CD pipeline and doing our deployments. So for that I have used a Terraform, and I have provisioned this infra, and then one EC2 instance. This will be using as a runner. So we'll discuss like what a runner is, and lastly we will be creating the Kubernetes cluster with the help of Terraform. So everything is done using the Terraform. Next I am just going to show you, this is my repository which is called DevSecOps CI CD pipeline. We will be dealing a complete project with this repo itself. So yeah, we can see like just ignore all of this and focus like in the repo we have the source code, and in the source code also like we have pom.xml. If you are familiar with the Java based application, definitely we will be having pom.xml, which will be having all the dependencies whatever it needs, and based on that it builds our project. So yeah, this is the thing. Rest of the things we will build on the go. So let's start. Okay, so now I have opened my VS Code as well as I have opened my Git bash. So let's start. As we have discussed, like this is a repo which I have cloned on my local system, and here is the source code. We can see this is a Java code. So this is a source code src, and it has one pom.xml which mentioned all the dependencies is need to get it built. Ignore all these things for now. Now let's focus on the Terraform code. So first of all, what I did is I have written the Terraform code. Let's see this. I have used the modular approach. So here what I did is we can see I have built different modules. So first I have written the VPC module where I have described like what VPC I need, and this one, and then in the main I have given the CIDR block of that VPC. So with the help of this VPC is created, and then this public subnet, private subnet, different modules I have written, and then once called it is saying like create one public subnet. So the public subnet CIDR will be this, and similarly one more subnet I have created. So similarly like this 11.3, and then one private subnet, this is 11.2. so likewise I have created VPC and its component. So next component is IGW, which is internet gateway. So I have created internet gateway module, and route table and route table association. So everything comes under the VPC component. So yeah, we can see, like I'll show you. If I'll go to console and see VPC, I have given my region is AP Northeast 3 and name is Onmo VPC. So let me see, main here Onmo VPC is the name, and my region is AP Northeast 3. Okay, so here I am doing all the infra provisioning, so yeah, this VPC has been created, we can see. And subnets, we have created 3 subnets. So these are the 3 subnets, 2 is public subnet and 1 is private subnet. We have the route table, and we do have internet gateway, okay, and route table association. We can see here it is associated to that particular route table. Okay, this one, this is a route table associated to these 2 public subnets. So yeah, our VPC is ready. Next thing what I did is I have created EC2 instance, and I have called that EC2 instance. But before EC2 instance, I should be having one security group which I need to attach to that EC2 instance. Okay, so I have created one security group, and I have allowed this basic 80.443.22 and 80.80. Since I will be doing connecting to this instance from outside SSH, so that's why I have allowed 22, 443 also, 80 because I will be deploying this application, and 80.80 for the application. So everything I have given as a security group, and this security group I have attached to this EC2 instance. So next module is one is this security group, and the next one is EC2 instance. So yeah, so I have called that EC2 instance group. What is there? Okay, let me go here. Okay, so EC2 instance web server I have created, which where I have given the key name, key I have used, and then AMI and this one. So and I have attached the group security group ID and which subnet I need to create. So I have created it as a in the public subnet, because this is a demo project. So yeah, we can see this as well, like when I'll go in the EC2, we can see, okay, we can see like here Onmo app instance. So where it is, let me see, main, in the main it is saying var dot just a minute, yeah, it is saying which one it is, yeah, Onmo app instance. Okay, so this is a modular Terraform approach. If you are familiar, you'll easily get it, like how I did it. Like I have created the modules and called it in the main, and defined the variables in the variables file. Also some variables outside of the variable, like in the main tfvars.tfvars file, and in the provider I have mentioned about the region and the provider. So yeah, this, with the help of this code, I have created the VPC, subnets, then route table, internet gateway, and its association. Next thing I did is security group and one EC2 instance. Why I launched one EC2 instance? Because while doing our CI CD, we will be needing one one server where we can run our CI CD pipeline. Like everything will require some compute, right? So for that I have provisioned one EC2 instance, and that we will configure as a runner in GitHub Actions. If we not doing it, there is other option from the GitHub which allow us to do by their own servers, but I have done on our provision server. Okay, so that EC2 instance is there. Now what we need to do is, we have infra, we have already, our infra is ready. So now let's begin with the CI CD. So let me tell you, like we have one our my laptop is here, okay, and then we have AWS console. In that AWS I have created one VPC. In VPC I have created 2 subnets and there is 2 availability zones. So here I have created 3 subnets actually, okay, and in this one subnet I have created one EC2 instance which we will be using for our GitHub Actions, and here is our GitHub repo. Okay, so now till now it is done. Next what I'll do is, yeah, so here it is, and then if we'll go in this repo and we'll go to settings, and here what we'll do is we'll create where it is, actions and runner. So once I'll do new host runner, it will give me some commands. This command I have run on that EC2 instance. Okay, let me start it. I have just started that instance. I have not created it, I have just started it because it was already created. So yes, so in this server what I have done is, whatever it is giving, right, like this same thing I have already done this, that's why it is showing us as a runner. Okay, here it is showing us as a runner. Okay, so the server is this server is idle and it is online, so we can see. Now what I need to do is, this is ready, right? Now what my aim is, like whatever getting changes in this repo, whatever is getting pushed in this repo, it should follow one particular pipeline and application should get deployed on our EKS cluster. Okay, so for that what I have done is, here we will be writing GitHub workflows. So how it is getting written is, first we will create .github and /workflow folder. In that we will be creating workflows. Okay, so here see this one, I'll do like don't worry, like I'll do the hands-on as well. So now this is a CI YAML. Here what I'll do is, okay, so now let me just do it. I'll just go inside this and yes, status. Okay, so there are a few things. Okay, fine, okay, fine, and main. Okay, so in main terraform dot main, just a minute, terraform code main में ये किया है मैंने, चला दिया है. Okay, fine. Okay, so now our runner should be up and running. So it is up and running, the server is up and running. Action runner cd action runner. Here we will be having 1 second, sudo svc sudo sh svc dot sh stop. Let me just stop it because it is configured on the boot. I don't want that. I'm running it as sh run.sh. So our runner is configured, and we can see that it is connected to GitHub and it is listening for the job. So here also we can verify, like in the settings and in the action runners, it is showing like, okay, it is connected now. Okay, it is connected now. So then I have written the basic workflow. Okay, here what we are going to do is, this is our GitHub workflow. We are starting our CI CD pipeline. Here let me just go back and see, this infra is ready, this runner is ready. Now what I'm going to do is, I'll make the changes in the code and I push to GitHub. This GitHub should run the pipeline, and in the pipeline what I have done is, first I will be checking like the basic unit testing. Okay, so once pushed, it should do the unit test. So for that, this is a code, like on push in the main branch, what the job should run, it should do the unit test of the source code. Okay, so this is a thing, and this is the test file. Here what it is doing is, where it will run on the self-hosted, which we have configured, and it will do the checkout there, and it will do the MVN test. Okay, so this MVN is also installed in the server. This server, the MVN is also installed. Okay, so this MVN is also installed here. So with the help of that, what it will do is, it will run the unit testing. So let's do it. We need to check, like once I will push this to my GitHub repo, the pipeline should get triggered. This is our first workflow. So let me see git, I was on the wrong path. So yeah, now if I will do git status, okay, so here it is showing something, right? So now what our pipeline shows is, once the developer commit the changes on push, it should get triggered. Okay, so for that, what I have done is, we have written one GitHub workflow. Okay, it is we write it in the .github workflow folders, and here I have written one main file, which will be calling the other YAML file for the different stages. So here we can see, on push on branch main, है ना, on push, जब भी push whenever the push will happen on the branch called main, okay, this unit test will get triggered. Okay, and it will use the test.yaml. In test.yaml, what it says is, like it will run on our self-hosted runner, and it will check out the code, and it will do the ambient test. So let's check it out. I'll just make a few changes, like I'll just make, suppose I have made the changes in the source code, and then I'll make the git status. So we have seen, like it is modified, then git commit -m, okay, demo1, and then I'll commit this file, and then git push origin main. So this file is getting pushed, and our source code should be updated. So now I'll go in the pipeline, and I can see, like this is just pushed. Okay, so this file has been pushed, and if we'll see in the action, so our pipeline should get triggered. So it is getting triggered, and if I'll check this one, I can see this unit test, and the first stage is passed, which is unit test. So unit test is passed, we can see it is a green. Okay, likewise we will do each and every stage, and we'll deploy the application on the EKS cluster. Okay, so yeah, now this is passed. Okay, so first stage here, once it is pushed, once the code is getting pushed on GitHub, the pipeline started triggering. Next is sonarqube. So let me write the code for the sonarqube. Here this is the sonarqube. I have just written it. I'll uncomment it and I'll see you. See, this is a sonarqube scan. What it will do is it will get all the secrets, and once the unit test is passed, our sonarqube scan should run. In the sonarqube scan, we are getting the code checkout, and then we have written the mvn compile sonar which will do the sonar scan, and it will perform the scan. Okay, so what it will do is, let me just make some changes here in the sonarqube scan maven and CLI. So okay, so okay, this one also and this one also, maven by maven by CLI. So I have made changes in the code, and again I'll just push it, git status. So this file has been modified. Okay, this file has been modified. So git commit -m stage 2. Okay, demo stage 2, paste, git push origin main. So again I have made the changes in the code and pushed it to the GitHub repo. Again the pipeline should get triggered, and if we see in our repo, just now demo stage 2 has been pushed, and if we'll go to action, we can see it is being triggered. And let's see, once unit test is passed, sonar scan is running, and it will take some time. So let it complete. It will just take some time, maybe 5 minutes also it may take. Let me just pause the video because it will take long time, and I'll just get you back. So yeah, we can see like sonar is also passed. It took around 1 minute 48 seconds, and yeah, this is also passed. So our 2 stages has been passed, 2 commits, like one was demo 1 and the second commit was demo stage 2. Both has been passed, and we can see our pipeline is working fine till unit test and sonar scan. Now let me write the code for Snyk. Okay, so yeah, one more thing, like for the sonar scan, we can see our sonar, this one, and let me see, loading and failed, getting pushed. Okay, 12. Okay, so this is the report, and if you'll see like why it is getting failed and still it shows the success. So since this is on the developer side, we need to coordinate with them and check whatever the issue in this code. So for as of now, for the demo purpose, I have skipped the testing so that my pipeline should be working for the next stage. Otherwise it would have failed, and it needs the dependency on the developer. So that's why it is showing here failed. But you can see the latest report has been published right now, like 12 of August 2101. This is the exact time now. So yeah, this report has been published on the sonar dashboard. The next thing is Snyk test. So I'll just make the changes. and let me see, just a minute. So now let's make the changes for the Snyk test. Snyk test will be what it will do is it will again check out the code and it will install the Snyk CLI in the runner itself, and then it will test our pom.xml. In the pom.xml all the dependencies and packages are mentioned, which version it is, so it will scan everything and give us the report, and then it will push to the dashboard. But here also, like, it will fail if any dependency or vulnerability found. So for that I have made it true, so that we can pass this stage, because this is the dependency on the developer as well as the security team, which we don't have now in the demo. So for that purpose I have made the stages and made it true. So let me do it, and like git status git commit -m, okay, demo stage 3, and in this paste git push origin main. So once our source code has been pushed, we can see in our repo where we can see it has been pushed, demo stage 3, and the pipeline has been triggered on push in the main branch, and we can see it is running the unit test, and then it will run the sonar scan, and then it will run the Snyk test. So it's like on every push, if I have mentioned the dependency and I have mentioned like which one is first, what should be the next, and what should be the next. So that's why first is unit test, and the sonar is depend on the unit test, and Snyk is depend on the sonar scan. So that's why it is running in the sequence. Let's wait. Once it is completed, I'll show you. So just wait for it. We can see like sonar has been passed, and then Snyk is triggered, so it is installing, and then it is running the test, and then we can see it is checking the pom.xml, and here is the result. Push to dashboard, so it is pushing to dashboard. It is our Snyk dashboard. Here we can see a few seconds ago, so it has been pushed, and if I'll go here, we can see what are the discrepancies we have found. So yeah, see 12 August 2126, okay, so 2126, and this is the hostname from where it is pushed, and this is the Snyk results. So if anything we found here critical, we need to check with the security team, and they'll give us the corresponding approach what should be done. Okay, so we can see our 3 stages has been passed successfully. Now let's move to the next one. As per this, what we have done is we are pushing the code, and our pipeline is getting triggered, and it is doing the unit test, and then it is doing the sonarqube, it is doing the Snyk. So what is next? Let's build it in the artifact. Like, we will build the jar out of this source code, because everything is scanned and passed. So let's build it. So next step is we will be building it. So let's write the code for build and archive. Okay, so once the Snyk test is passed, it will build and archive it. Okay, so let's do it. I'll do git status, and I can see this file has been modified. So git commit -m, okay, and demo stage 4, okay, and let's do it. So this has been passed, and git push origin main. Okay, so it is passed. If I can see here, so this is the repo. Okay, and it is demo stage 4 has been committed, and like in the action, the pipeline has been triggered, demo stage 4, and again we can see like it will go through it. So once it start building, I'll show you. So yeah, we can see like unit and sonar has been passed and Snyk is running, and once it is passed, then our fourth stage, which is build jar or build artifact, will be triggered. Let's wait for it. Yeah, so here our Snyk has been passed, and then if we see our build artifact, so it's getting triggered. Here is the view. Okay, so here we can see unit test is passed, sonarqube, Snyk, and build triggered. So here we are building the artifact. It will give us a jar file as an artifact. With the help of that jar, we should be building our Docker image. We have Docker file for that. So let's see that it is built. Okay, it has been built, and we can see one artifact has been generated. So we can see here, okay, in the artifact we can see here, just a minute, here, yeah, we can see this build artifact. So artifact has been available, and from here we can even download it, and then this artifact can be pushed to JFrog Artifactory. So next step should be pushing this artifact to JFrog Artifactory, but while doing this demo, I noticed that my JFrog is, the trial has been expired. So for now we can skip this. Anyway, we have our artifact ready, so that is fine for now. Now we can skip and build our next stage, which is building the image out of this jar. So for that we will be needing our Docker image. So let's see, this is our Docker file, and in the Docker file I have mentioned like what is the Eclipse version I will be needing to build this jar, and then I have set the work directory in the container and copy whatever target we have generated, right? This target has been generated in the work file of the work folder of that pipeline in the runner. So in the action runner, if you will see, like here I'll show you, in the action runner, you can see underscore work, and then underscore this one, and this one, again this one, and here target, and in the target you can see this is the jar. Okay, this has been created. Okay, so yeah, this is the jar which has been created, this one actually. Okay, so 12th of August, yeah, 16/4/16/1. So this jar has been created, and like it is just replacing it with the original and this one. So that's fine for now. Now what we can see here is our artifact is ready. We have verified it, like it is available in the GitHub itself. It can be pushed to the JFrog Artifactory. As of now we are skipping this one, and then we are building our whatever target we got. We are building it as a pet clinic.jar, and we are exposing it on the AT. Okay, so this is our Docker file. With the help of this we should be getting one image build. So let's do that. For that, in the workflow I have mentioned like Docker build, it seems. So let me build the image of this artifact. So once this build and archive is successful, it should be building it. So let me just check it. Here we are doing the checkout. We are checking what is the head of this. Okay, and we are mentioning the tag, and in that tag we are downloading that artifact. Okay, we are downloading that artifact, and then we are building the Docker image. So Docker build hyphen f docker file, and this is the pet clinic. So and this is the tag. So with that we are building the docker image. So let me just push it git status, and we can see this file has been modified. So I'll just mention git stage 5. Okay, and we can see here again the same thing. We can see our commit is demo stage. Okay, sorry, this is a commit and this is a push. Okay, yeah, so it has been pushed. Now we can see this is now demo stage 5, and we can see the pipeline has been triggered. So in the action demo stage 5, and again it will run each and everything. So once it will come here, I'll just resume the video. So yeah, we can see like 3 has been passed, and 4th one like build artifact is in the progress. So it will not take much time. Let's see. Okay, so it has been built, and this has been uploaded. Okay, the GitHub remote artifact, so it has been built, and from the local it has been also uploaded. So here we can see like last time as we saw, yep. So yeah, this is ready again. Okay, produced during runtime. So this has been again created, and then the docker build. So here what it will do is it will build and it will create the docker image. Okay, the next one is push. So what it will do is it will create the docker image. So how we can verify it, like we can see, just a minute, like we can see the docker build has been passed. Okay, so we do have our build ready and we do have our image ready, but it is locally, like in the git. This is my GitHub, and here we can see this is the repo which I am using for this image, and I can see everything is pushed 1 day ago, but there is no pushed today. So it is still in the local. So to verify that, we can see like just a minute ago I did docker images, so there was no images, but now it should be having one image. So image, sorry, docker images. Okay, so docker images shows like the pet clinic has been created, and this is the tag, and this is the image ID, and it is created a minute ago, 321 MB. Okay, so this is the image created. Now we should be here. If we come back to our slide, here we have build image and we have tagged the image. Now we need to push that docker image to the docker hub or docker registry. So for that, let's do it. Like I'll just write the code for docker push. So let me use this docker push, and if we see the docker push, what we are doing here is we are running on the self-hosted. We are checking out the code, and you know, it is using my docker login. So it is picking from the docker hub token and docker hub username. So everything I have stored in the repo, in the secrets, like in the settings and in the secrets action. Here you can see each and everything has been stored, like sonar token, Snyk token, jfrog, URL, whatever you know, sensitive data is there, username, passwords, keys, everything we have to store here in our secrets as a variable, and we need to pass it in our pipeline with the secrets dot this token name. So yeah, it is using that, it is getting logged in, and then it is you know, Docker images it is doing and checking if it is locally available or not, and then it is tagging the image, and then it is pushing to docker push and my repository. It is pushing to onmohub sports, which is what my repo looks like here, onmo sports. So here it is pushing with the github sha. Okay, and then this part is to be discussed later, so we'll not go through it, and I think it will give error because this is will not be okay. So let me just comment it out, or let me just take it out of this. Okay. Sorry for that. Where should I put it? Oh, here also I should not put it. So what I'll do is I'll just let me put it somewhere. Okay, fine. Okay, so now I have what I am doing is, in this stage I am pushing the docker image to the docker hub. Okay, so this is the last stage for our CI pipeline. So what we will do is we will push the docker image to docker hub. Once let me just verify it, everything is one day before. Okay, so now let me just do it, git status, and okay, git commit -m. Okay, demo stage 5, this one, paste. Okay, sorry. Git commit -m. Okay, and then git status, then git push origin main. Okay, it has been pushed with the commit stage 5, right? So let me check again here. Now stage 5 and started building. Again I'll just show you once it is success, because unnecessary it will just take some time. So let me just pause the video. We can see like the sonar is getting run, and then sonar is completed. Now the Snyk test is getting run, and then it will build image, and then it will push. So just wait till here. It's on the build stage. Let it be done, and then this conclude our CI pipeline, but there is much to do in our CD part. So just it will take another 20 minutes it seems. Watch till the end, and I'll show you the CD part as well, where we will be using our Argo CD to sync up with our GitHub, and then it will be deploying on our EKS cluster. So for that we also do need to create our EKS cluster using Terraform. So again we will go back to our Terraform, write some code for the EKS cluster creation. It will get created, and we'll set up the Argo CD, and then we'll do the deployment. So just wait and watch. Okay, and then we can see it has come to the end. Like this is a Docker push. Once it is pushed successfully, we should be able to see our Docker image pushed here. So let's just refresh. Okay, not now because it's still running. Okay, it has been pushed, so just wait it. This is still 1 day ago, and less than a minute. Okay, so now this is the image which has been created, like created in the previous stage and pushed in this stage. So this has been pushed. Our CI part is complete. Now let's start for the CD. For that we will be needing the EKS cluster first. So let's create that. Okay, I hope the CD part is clear and you are able to follow up till here, like CI to here. Okay, now you can see some part as commented. So this is what I have done is, I have tried multiple ways, like I have deployed using normal Docker, and then we have deployed using GitHub Action itself, and then I have deployed on the normal Kubernetes cluster, then EKS cluster. So for that it has been just to test it out, so you can ignore this part now. Okay, this is called the GitHub workflow. So let me just brief what we have started. So this one, right? So CI part has been completed using GitHub Actions, and you have seen the GitHub workflow and security scans, and build. The image build is complete. Now to deploy it using Argo CD, this part is remaining. So let's jump into it and do that. So okay, so now what I'll do is, here you can see in my console, AWS console, here I have only one instance. Okay, I have only one instance, and in the Kubernetes cluster you can see in Osaka there is no cluster. Okay, so instead of creating from here, what I'll do is I'll create it from Terraform. So let's write that code. I'll go to Terraform code, and then what I'll do is in the main I will create the cluster. So this is a cluster code. Here we will be using EKS cluster module, and we will be attaching security group, subnet ID. We will be provisioning our cluster in the public subnet of this, and we are attaching one IAM role for that, because we do need the cluster role and node group. So in node group also we will be needing one role. So here this role has been created. Here if you'll see, I have one IAM module. In the module section you can see we have one IAM module. In that module I have created cluster role, and then I have created EKS node role, and these two roles has been attached to this cluster. So in the EKS cluster we have this code. Here we have given which VPC ID we need and what security ID we need, what it would be the cluster name, what will be the role ARN, and what will be the version. So while calling in the main, okay, we can see this is the code, and same goes with the EKS node group. So for that what I have done is, first I have written the IAM roles for cluster as well as the node group, and then individual module for EKS cluster. Here you can see EKS cluster, and then you can see EKS node group. So these are the module, and in the main I have called that modules. Okay, so let me just do this. I hope I know the better way to uncomment it, but for now that is fine. Okay, so fine. So here what I have done is, I have written the code to create the EKS cluster as well as the EKS node group, and we will be needing two nodes, and maximum size is 3 and minimum is 1. So for now, since the desired state is 2, there will be 2 nodes which will be created under this cluster, and it will be T3 medium, environment would be dev, and these are the details. You can go through it. So now let me just create it. So I am going to do here, first of all I'll do Terraform init, I'm so sorry, init. It will initialize the modules. Okay, and Terraform has been successfully initialized. Okay, then I'll do Terraform validate. Okay, it will validate what are the, if there is any syntax error or undefined variables, undeclared variables, everything it will show here if we missed anything in the code. So we should always do Terraform validate. If it is success, then we'll proceed for the next, which is Terraform plan, and we'll do Terraform plan, and output we will save in TF plan. So let's do it, and it will show like what will be the changes in our infra. Okay, so yeah, just wait, it will give us the plan. Here you can see whatever is existing, it will just refresh it, and what is the new. So it is saying like 2 to add, 0 to change, and 0 to destroy. So we are safe, like nothing is getting destroyed and nothing is getting changed. Only 2 resources will be added. Now we will see like what will be added. So it will add the cluster, okay, will be created, and the cluster details, few are given, few will be known later. And then we can see the node group which will be created. Okay, so yeah, we can go ahead, and I'll do Terraform apply TF plan, because whatever we have saved in TF plan we need to apply it. So let's do it, and we have done the Terraform apply. Now it will take around 10 minutes, because for me the cluster creation always takes around 6 minutes for cluster and 2-3 minutes for node group. So if you want, you can wait, or I'll just pause the video. So I'll just resume once it is about to complete. So just wait it. So yeah, we can see like it's almost 4 minutes 30 seconds, but still it is getting created. And here also we can verify it. Here in the cluster we don't have any cluster. Okay, we don't have any cluster. So just wait for it, and it's getting created around 5 minutes. Almost it takes 6 minutes or 5 minutes. So yeah, so as I mentioned, like it takes around 5 to 6 minutes. So we can see in the 6 minute it has been created my EKS cluster. Okay, and now it is creating the node group. Okay, so let me just verify it in the console. If I'll just go back and do the cluster, okay, yeah, we can see my EKS cluster has been created 7 minutes ago. Okay, so the thing is it will not show here, but once it will complete, it will show here. That's why it is taking around 7 minutes. It is showing around 7 minutes. So my EKS cluster is ready. And if I'll go in the commute and see the node group, so node group is getting created, and that's what dev node group. Okay, so it is getting created, and let's just wait for another few seconds. Okay, so you can see like after 1 minute 50 seconds our node group has been created, and the name is dev node group. So here as we saw here, the node group has been created and 2 minutes ago, and this is the subnet ID where it has been created. Minimum is 1, maximum is 3, and desired is 2. So 2 nodes would be there. So once I'll go to EC2, we can see here initially when I saw when I show you, it was only one instance, right? And now you can see two more instances are there which is getting initialized. Okay, so yeah, this is our see here it is our runner instance, and this two is the cluster related node. So it is showing our security group which is attached to it. Fine. So now, okay, so now what we need to do is since as per our CD pipeline, what we need to do is we need to install and configure the Argo CD operator. What it will do, it will try to sync our GitHub repository with the deployment. So for that, first I need to configure it. So let's do it. So we have verified like our two instances are created. So now what we can do is what we'll do is I'll just connect this Kubernetes cluster, EKS cluster, via my CLI. For that, I'll just update my kube config and I'll provide my cluster name and the region. So for that, I'll run AWS EKS update kube config and region and name. I'll just run this command. Okay, so the context will be updated, and then I'll do like kubectl get nodes. So for this, I have also installed kubectl. Okay, so I have installed kubectl on my local machine. With the help of this, I can manage or talk to the Kubernetes API server to give the commands. Okay, so for that you will be needing kubectl, which I have already installed. It's just a binary. We need to install and set the path. It will work. Now kubectl get nodes, I can see these two nodes are up and running. Now what I'll do is I need to get like kubectl, okay, kubectl get get ns namespaces. So if I'll check, the namespaces is default, kube node, kube public, and kube system, and kube node lease. Okay, these are the namespaces available. Now to install the Argo CD, I'll be needing one more namespace. So I'll do kubectl create namespace Argo CD. Okay, so I'll create the Argo CD namespace. That namespace has been created. Now I'll do kubectl get ns. So we can see Argo CD namespace is available. So whatever we will install in this namespace. So this is the command to install the Argo CD. Here we are doing Argo CD in the namespace Argo CD. Sorry, here we are doing kubectl apply to this YAML install. Okay, it is having multiple manifest files, and what this single command will do, it will set up our Argo CD in the cluster. So let's wait, let it install. Okay, okay, so this has been installed. Now if I'll do kubectl get svc, so we can see this is the service which is getting running, but we have installed in namespace Argo CD. So we'll check for this Argo CD, and we can see these are the services which is running under the namespace Argo CD. Here we can see there are multiple services which has been set with the single command, and we can see the Argo CD is up and running. Now here we have the Argo CD server. So if we'll see this, okay, kubectl edit svc Argo CD server. Okay, in the namespace Argo CD. So we can see this command. Okay, we can see here they are using the type as a cluster IP, but what we are doing is we have our runner here, okay, and we have our cluster here somewhere. In cluster we have 2 nodes, and in that nodes we are running Argo CD. So for that purpose, since it is we will definitely need load balancer so that we can access it on our browser, okay, through the internet. So that's why I will make the service as a load balancer. So for that we need to add it. So there is the one way is to edit it and save it and everything, but we can do it via one patch command. So I'll do kubectl patch, and with the help of this command kubectl patch, this Argo CD, this type load balancer, okay. So now it will be the load balancer type, okay. It has been patched, matlab it has been updated. Now if we'll see, it is showing as a load balancer. We'll do kubectl get cc Argo CD, yeah, okay. So now this is, I think it should work. Okay, before it is showing something else. Let me just verify it. It is not showing it. Okay. Yep. Okay. So nothing. The service was getting ready, and now we got the actual DNS. Okay. So, the actual domain. I'm so sorry. So now I'll just proceed because it is not HTTP, but okay, we are accessing it on HTTP. It is not secure, but let's just for the demo proceed. Okay, and we can see our Argo setup is ready. Now its username is admin, but to get the password we need to get it from how we did in Jenkins initial secret password. Same we need to do here. So for that, what we'll do is I'll get the secret from the Argo CD initial admin secrets. Okay, so this is the secret. We need to get it, okay, and then what we need to do is we need to encode decode it. So what I will do is I'll just run the single command which will do everything and give me the password. So I'll just run this, and here is the password. I'll just copy it, okay, I'll just copy it and I'll just paste it, and we are able to log in our Argo CD. Now here what we need to do is we need to make sure like we are syncing our repo with our this one, okay, with the Argo CD and in the cluster. So what we are doing is we are creating one app. Here we are showing as pet clinic app, okay. Then the project name, default, manual, automatic, it should be automatic sync, remote repository. So I'll just take my repository. I'll take my repository here. This is the URL. I'll just take this one. Just a minute. I'll just take this one and I will give a remote repo. Okay. Then in the path. Okay. So which path actually I want to be synced? So definitely it's cluster deployment. I'll be needing the manifest. So I'll give this Kubernetes path. I'll be giving this Kubernetes path. So where it is, yeah, so this Kubernetes, then branches, okay, head, fine, cluster default, because this is the same like the same cluster where we have installed the Argo CD. On the same cluster we are going to deploy our application. And the namespace, so I'll be deploying in default namespace, okay. And if we want, we can create any development or production namespace, whatever we want, and we can proceed accordingly. Then I'll just create the application. So we can see our application has been created. Now it is synced also, but we are missing one thing, okay. What it is? there is one manifest and it is getting deployed. Okay, fine. So it has been deployed. If we kubectl get svc, okay, and then in the default it will show my app service. Okay, my app service. So this is the thing. Okay, and I'll just copy it, and if I'll hit it, I can see my application is up and running. So we have successfully deployed our Kubernetes manifest. We have successfully deployed our application using Kubernetes manifest on our EKS cluster. But here is a catch. Just give me 2 more minutes and we will do it automatically. So we'll run the end-to-end pipeline. So here, if you can see, if I'll refresh also, if I'll make any changes in the repo also, it will just deploy the same image, because you can see in the repo, sorry, in the manifest file, it is showing us as 975. It is not dynamic. So for that, what we will do is, what we want is, we need, like, whenever the new image is getting created, it will sync, and it should be deployed with the new latest image in our EKS cluster. So for that, just do this thing. Like, what we'll do is, we will be doing docker push, right? After docker push, what we will do is, it will push, then with the tag, it will update our GitHub repo manifest, and Argo CD will sense, like, okay, the new version has came, and it will deploy it. So for that, I'll just do this docker push thing, right? Docker images. Here what I'll do is, I'll just paste my changes. Okay, so here what it is doing is Kubernetes manifest with new tag. It is pushing to the Docker Hub, then it is updating the tag, and then it is committing in the in our repo. So once it will be committed in the repo, the pipeline will get triggered on the push, and definitely it should be applied. So this is the last time we are running our code, and it should run end to end from source unit test to the deployment, and it should be having the latest version running. So let's do it and and this is the end-to-end deployment. So just do it. Okay, let us do it. So let me just go back here, ll, okay, git a status, okay, and okay, so git commit -m demo stage final deployment end to end. Okay, git push origin main. Okay, so now let me go back here. We can see demo stage final deployment end to end actions. It has triggered the pipeline. Now what it will do is, unit test, sonar, Snyk, build, docker, push, and then deployment. Since I have made the thing in the same same configuration, that's why it is not showing, or we can put the configuration in the next stage and call it. So yeah, we can do that. Just wait and watch. Here we can see the image is 97515, right? Now just wait and see. Here 34 minutes ago, okay, 43 minutes ago, okay, we should be having one image after this, and that should be deployed, and we will be completing our end-to-end CI CD pipeline. Just wait and watch. Okay, I'll just resume the video in a minute. Okay, so now unit test, Sonar, Snyk and build has been passed. We are on building the Docker image. Let's see, Docker image has been built, and once pushed, right, once it will push, it will also send to the Docker hub, and it will also update the tag and push in the Git repo. So it will update our manifest, and once the manifest has been updated, the Argo CD will run. Argo CD will sense like sync, and it will deploy the latest version. So that's what we need to test it. Okay, so it has been built. Now this is very important, push. Okay, so let me just see, it is still not pushed. Okay, so it is still not pushed, and let me see the Argo CD thing. Okay, get SVC Argo CD. So yeah, this is my Argo CD setup. It should not ask me the password. Fine. Okay, so now you can see here it is running. Okay, sync, okay, healthy, synced. Okay, 14 minutes ago. Okay, it is 14 minutes ago, but now see. Okay, so this is the new image, which is C4 C8. Okay, less than a minute. Okay, C4 C8. Okay, now what happens is, let me just refresh it, and it is getting synced C4 C8. Okay, and it has been deployed. Now you see, this is still, it is showing. Okay, let me just refresh it. Yep, so what it started doing is, it will deploy the new one and destroy the old one. Okay, so it is creating the new pod, and it will start deleting the old one. So here also we can see kubectl get pods, see, running container creating. Okay, and just see it, pods -w. Yeah, so just see how it is done. So a minute ago it started, and progressing, synced. Okay, so see, one has been created, another one has been deployed. Now one more is getting created, and another one has been deployed, destroyed. So now we are having the new one. You can verify it. It is having C4 C8 one. Okay, few seconds ago. So we have successfully deployed the latest version of our application, and here we have completed end-to-end CI CD pipeline using GitHub action, which is from the source code to the deployment. Now we will again access our application. Okay, so git svc, and this is our application URL, and it should be up and running. Yep, thank you so much for watching this video. We have implemented CI CD end-to-end with the DevSecOps practices. So yeah, this is it from my side. See you in the next video. Thank you.